Hello and welcome to this TDD tutorial, and welcome to the sixth section of this course. In previous sections we had the chance to learn how to use mocks during our test-driven development. We saw how we can manually mock objects, and we saw how we can mock them using mocking frameworks. Now, in this section we are going to talk about modularization of the code and inversion of control. To be more accurate, in this section we are going to examine dependency inversion principle, inversion of control, factory method design pattern, abstract factory design pattern, and we are going to see how we can use delegate types. So let's start from the first video in this section, dependency inversion principle and inversion of control. In this video we are going to talk about last but not the least solid principle, dependency inversion principle. And we are going to see what inversion of control is. Dependency inversion principle is actually composed of two rules. First one goes like this. High-level modules should not depend on low-level modules. Both should depend on abstractions. And the second rule goes like this. Abstractions should not depend on details. Details should depend on abstractions. This looks something like this. High-level classes have no dependency on low-level classes and vice versa. They both have dependency on abstractions. When we apply this principle in our code, we got into a state where low-level objects are actually defining contracts that high-level objects can use. This way, high-level objects don't need to care about specific implementation of the low-level objects. If you ask me why we are doing this, well, basically we are removing direct dependencies from our system. This way, our code is not as tightly coupled, and we are able to mock the classes as we wish, and isolate part of business logic. Let's take a look at two examples. One will follow dependency inversion principle, another will not do that. We will see implementation of calendar class that should use events and reminders. So let's go to the code. Okay. In this first example, we are going to see how you shouldn't do things. Basically, this first example is not following dependency inversion principle. First, here is event class. It has these properties and this start event method. Then here is the reminder class. It's pretty similar, but it has a start reminder method, and it also had some properties. Finally, here is calendar class. Of course, you can see that calendar class has direct dependencies on event and reminder. This is very tightly coupled and impossible to mock anything. You can see that we are also using new operator here, and we know that we will have problems with this. We had similar situation in previous section, if you remember, when we didn't want to use employee service as a hard dependency in equipment service. So, what should we do here? Well, as you can notice, calendar is a high-level class and event and reminder are lower-level classes. So we need to create some sort of a contract for event and reminder, and that is exactly what we do. We added iCalendarItem interface. This interface will be implemented by event here, and we will define the same properties here, and by the reminder like this, and defining the properties of the reminder. Then the calendar can use this abstraction, basically this interface. And it is using it like this. We created a collection of items, which is passed through constructor. And also in start method, it is able to call start method on each calendar item in this collection. Notice the calendar itself will receive this collection through constructor. This means that this is easily mockable. As you can see in our test here, we created one item, added to a collection here, and passed it into a calendar, and verified that this start method has been called. Finally, let's discuss what is inversion of control. There are two definitions that are explaining this in a valid manner. First one is from Wikipedia and second one is from Martin Flower. Second one is a bit paraphrased. First one, from Wikipedia, says that inversion of control is a programming technique expressed here in terms of object-oriented programming, in which object coupling is bound at runtime and the assembler object is typically not known at the compile time using static analysis. That is exactly what we have done in our calendar example. Calendar doesn't know what event and reminder are in compile time. Martin Flower is saying this: inversion of control is a common pattern that helps wire lightweight containers or assembly components from different projects into a cohesive application. Inversion of control is a technique that we are using to achieve dependency inversion principle.